In this lecture, we're going to study the electric field. And the electric field is a measurement of the force per coulomb of charge a test charge experiences in the electric field. And so that equation looks like this. The electric field E that exists at some point within the electric field is equal to E equals F over Q sub naught. Now E is the electric field measured in newtons per coulomb. F is the force measured in newtons. Q sub naught is the charge that's in the field. It's not causing the field. This is the charge that's in the field. It's a test charge that has a force acting on it because of the electric field. To calculate the electric field due to a point charge that is causing an electric field, and this is a different situation because this is the charge is actually causing the field. In the previous equation, the charge was in the field. Here, we have a charge causing the field. And so that equation is E equals KQ over R squared. E is the electric field in newtons per coulomb. K is the electrostatic constant. It's that 9 times 10 to the 9th newtons per meter squared. And Q is the charge causing the field. And R is the distance away from the charges. So that R value is the distance from the charge, how far away from the charge you want to solve for the electric field. Now we want to look at the electric field lines. Electric fields are always directed away from positive charges and towards negative charges. Electric field line always shows the direction a positive charge would be moved in if you placed it in the electric field. Here's an example of what the field lines might look like for a point charge. They're going outwards from the center. Here's what they might look like for 2 point charges. Here's what they look like for 2 point charges. One's positive, one's negative. It's a dipole. Here's what it might look like for a charged plate. Here's what it might look like for a capacitor or a charged plate pair. And here's what it looks like for a negative charge. You see the arrows are pointing inwards. Here's if you have a dipole, a positive charge and a negative charge. It goes out of the positive into the negative. And if you placed a positive charge here in this field, it would actually, the positive charge would actually move along that red line. Here's electric field lines for 2 positive charges. That's what that looks like. And here's for 2 parallel plates. Now when we work with parallel plates, you have a positive charged plate and a negatively charged plate. And electric field lines go from the positive to the negative, but we assume that the electric field is the same everywhere inside. We ignore any fringing effects that you might see here. There's a little bumped electric field. We assume that the electric field is the same everywhere, straight across. Now we want to look at what the electric field inside a conductor is. Now a conductor is like copper, anything that conducts electricity, the copper or whatever. And if you go inside the conductor, if you put charge inside the conductor, the excess charge within a conductor moves out quickly. And it moves out to the surface. So you put this charge on the inside, all that charge moves to the outside very quickly. Here's a look at a positively charged plate and a negatively charged plate sending electric field, and we have this conductor that's on the inside here. And you'll notice that the negative charges in the conductor line up with the positive side of the plate, and the positive charges are lined up with the negative side. These negative charges here push away those negative charges there. But inside that conductor, the electric field is 0. The charges go to the outside part of the plate. Here's even another situation where you have a positively charged object, a point charge, surrounded by this conductor, and you'll notice that the electric field lines go out to the conductor, and then inside the conductor, electric field is 0, and then once again outside the conductor, you see the electric field lines go outwards. So there are no electric field lines inside the conductor.